In this video, we're going to study some examples of kinematics using integration. When we were studying derivatives, we have already discussed some examples of kinematics problem. So let's say we have a function s of t, and this is displacement. If we find the first derivative of that, we will have velocity. Or we can write it also as v of t. Now, if we get the second derivative of this, then we shall have acceleration, which can also be written as v prime t. Okay, so there is, please take note of the difference between velocity and speed. Velocity may be positive or negative because it tells you the direction where it's going, while the speed is a scalar quantity, so it shall be in absolute value. Now, in integration, we will be doing the opposite. So, if the given is v of t, if we integrate this v of t dt, then we go back to displacement. When we integrate a of t, a of t dt, then we shall have velocity. We have here a displacement function s of t equals 2t cubed minus 21t squared plus 60t plus 3 for time from 0 to 7. Now my question is this: from time 0 to 7, are we going to have just one straight line? The answer is no. Why not? Because it's not a linear function. It is a cubic function. You can see in this motion diagram, by the way, we also discussed motion diagram when we were studying derivatives. You can see in this motion diagram that we have some turns when time equals m and when time equals n. Now, how do we find the time when there is a change in direction from going forward to moving backward, or from going to right then moving to the left? How do we do that? And at the same time, how do we find this distance from the origin? One way of finding the time when there is a change in direction is to graph the function. So you can see here, our x-axis is time, and this is the displacement. So at time zero, this is where we started. The displacement is 3. At time equals 2, our displacement is, we are at 55. So it's moving forward, but once we reach this part, uh, going up, there is a change in direction. So we are moving up here. Now we are moving down. So at time 5, we reach this point, which is equal to 28. And again, from here, we begin changing direction. How we ascend. Okay, so how do we put that in a number line? Okay, so let's say this is our um, distance function. This is our distance diagram. Okay, let's have here 0. We are at 3 when time is equal to 0, and then we are at 55. Say 55 here. So from here, this is a time, let's change it. This is a time equals 2. So we move from here at time 0, that's our starting point. And then from here, we change direction. So up to down or right to left. So we change direction going to this point at time equals, so at time equals 5, we are on, where is that, 28. And then from there, when we reach that time 5, there is again a change in direction. So we move until we reach time 7. The question is, what is the displacement? So let me write here, what is the displacement from where time is equal to 0 until time is equal to 7. So let's try to find out t when t equals 7. So I hope you understand how we're getting the answer here. We can just substitute for the formula s of 7. So this will give us a distance, okay, that distance. So you take, okay, the formula again is 2t cubed minus 21t squared plus 60t plus 3. So you're going to substitute that and you're getting an answer which is 80. So somewhere here at time 7, time equals 7, you have here 80. I think it's in meters, I'm not so sure, and time is in seconds. So the displacement from 0 to 7 is actually how far you have from where you started. So the solution for this one is 80 minus 3 equals 77. And then you affix the unit. I just forgot what the unit, what was the unit used. Okay, the next question is, what is the distance covered from time 0 to time 7? So from where your time is equal to 0 until it's equal to 7. Okay, so we will compute all the distances. Let me use other color here. What's the best one to use? Maybe this one. Okay, so from 3 up to this point, 3 to 55, that is 52. That's the distance covered. And then from this point, 55, you move until 28. So this is 27. And then from this point, 28, you move until you reach 80. So how much is that? 52, right? So the total distance covered is the sum of these distances, 52 plus 27 plus 52. So that's equal to 131. Okay, so please take note of the displacement, which is 77. Take note of our answer, and the distance, which is equal to 131. Uh, my next question is, what about if we don't have a calculator or GDC to graph the function, or we don't know the graph of the function? How else can we find the displacement and the distance knowing only the displacement function? Okay, my question was, how do we find the distance and displacement of this function, and how do we draw the sign diagram if we know only the function and there is no graph that will support our answer? So I just put here the graph for the sake of discussion. Now, what we can do is, since, let me write here, the time frame is from 0 to 7. And we know that it's not a straight line. There will be turns. So when there is a turn, means there is a change in direction at some point. So where the question is, how do we know where is that point in time where there will be a change in direction? So take a look at this. So what does this remind you of? The slope. Okay, so we're getting the slope. That means we're getting the first derivative of the function. So we have uh, s of t equals 6t squared minus 42t plus 60. And recall how we find the slope of the tangent line. So we equate it to 0. 60 squared minus 42t plus 60 equals 0. And this gives us two values of t, which are 2 and also 5. And let's say we're asked to draw the motion diagram from 0. The displacement could be seen as area under the curve. So take a look at these two examples. So the first one the first one is similar to finding the displacement. So here we have area 1, area 2, area 3. It's the same as area 1 minus area 2 minus area 3. So we are getting the net of the areas. Whereas for the total distance, this is similar to finding the total area. So we have area 1 plus area 2 plus area 3. Take note of this. If v is the velocity function for a particle moving along a straight line, then the integral of vt dt from t1 to t2 is the same as s of t sub 2 minus s of t sub 1. That is the displacement from time 1 to time 2. And if you get the absolute value of the velocity, then you will be getting the total distance traveled from time 1 to time 2. Consider this example 14 from your book. A particle moves along a straight line such that its displacement s in meters from an origin O is given by s of t equals t squared minus 40 plus 3 for all t greater than or equal to 0 but less than or equal to 5, where t is time in seconds. The first question is to find the velocity at time t. So that's very easy. So velocity is simply the first derivative of t. So that's equal to 2t minus 4. Okay, so for letter B, find when the particle, so we're looking for the time when, and then we have to identify whether it's moving to the right or to the left. By the way, you can write here our first answer, which is 2t minus 4. Okay, for the next one, letter B, uh, when is it moving to the left or to the right? So what are we going to do is to find the point where it is at rest. So that's going to be where our v of t equals 0. So we have 2t minus 4 equals 0. That gives us t, which is equal to 2. Now the question is, uh, are we moving from the origin at time 2? Are we going to the left or to the right? So how shall we find it out? So what we can do is to substitute the displacement function by time 2. So that gives us negative 1. So this is actually the displacement, which is at the left of the origin, meaning to say from we're moving to the left from what time? from time, where shall we write that? 0 to t to where t is greater than 0 and less than 2, we have a velocity which is less than 0. So from 0 to 2, it's on the left. Okay, let us write it here. Where time equals 2. So we can also say that at this interval, it's moving to the left. Okay, so draw a motion diagram for the particle. So let's have this as our motion, displacement s of t. And then, so we need to find our s at time 0. We already have this one. And then also s at time 5. So we use your calculator and solve for it. So we have here 3 and then we have here 8. So let's begin at the time. Let's use this color. At time equals 0, we are on 3. And then at time equals 2, we are on -1. So the movement is from here to here. And then at time 5, we are on 8. So there is a change at time 2. Okay, so that's the motion diagram. So if we'll be asked what the, so we're done with letter C. So if we'll be asked what is the displacement, it's simply S of 8. Is it 8? S of 5 minus S of 0. So that's 8 minus 3. That's equal to 5. And if we would, okay, remember it's 5. If you would like to find the distance, so we can write here. It's a total distance traveled. So from 3 to -1, that is 4. And then from -1 to 8, that's 9. So it's 13. That's the distance traveled in, is this in meters? Uh, yeah, in meters. So in meters. Okay. So now write definite integrals for the particle's displacement on the interval 0 to 5 and for the distance traveled. Okay, so let me clear this area. So for, it's taking time. So for letter D, you will be using integration for calculus. Okay. So we have here for displacement, it's the integral of the function from 0 to 5. What is that function? The v of t. What is our v of t again? 2t minus 4 dt. So this is going to be our displacement, the integral of the vt. And then for, okay, wait, by the way, our answer here is 5. You can use your calculator and check that out. And then for the total distance, it's from 0 to 5, but you get the absolute value of the pt, 2t minus 4 dt. It gives you 12 point something, and it's around 13. Okay, so you can see that it says we verify, but we have already done that in part C. Okay, you can pause this and read the problem. What we are after here is to find the distance and displacement of these graph. The function is not given, instead we are given a graph. So what we can do is like what we cited a while ago. To find the displacement, we get the net of the area. So area 1 minus area 2 minus area 3. And for the distance, we get the total of the area, A1 plus A2 plus A3. Okay, we can find the area of this one. This is a trapezoid. So where these are the bases, how many is this? 1, 2, from 3 to 5. So this is 2, and this is 6, and the height is 3, right? So base 1 plus base 2, 2 plus 6 is 8, multiplied by the height, which is 3 over 2. So 8 divided by 4, so we have here 12. Okay, here we have a triangle, area 2, where 1, 2, 3, the base is 3, and the height is 3. So 3 times 3 divided by 2 equals 9 over 2, or 4.5. Here from the time is from 0 to 11, right? So 0 to 11 here. Our height is 3 and the base is 2. So our area is 2 times 3 divided by 2 equals 3. Okay, going back to this one, we have 12 minus 4.5 plus 3. So that's going to be 15 minus 4.5 is 10.5. That's a displacement in terms of what's its meters. And for the area, we just add everything. So 12 plus 4.5 plus 3. So 16, 17, 18, 19.5 meters. Okay, that's how you do it when the function is not given. So you won't be getting the integral because the function is not given. To practice your skills, solve the following exercises and then try to compare your answers at the answers that can be found at the back of your book. This is a continuation of the exercises. Continuation also of the previous exercises. The following hints will help you remember how to solve the problem. So if you see the word initially, it means the time is 0. And if the particle is at rest, that means the velocity is equal to 0. And to know if it's moving right or up, you solve for v of t. And if it's greater than 0, then it's moving up. And if it's less than 0, it's moving down. Okay, if Vt and At have the same sign, it's speeding up. We discussed this also in derivatives. And if Vt and A of t, or velocity and acceleration, have different signs, they are slowing down. Kindly recall or go back to uh, slides or PowerPoint that I sent before that shows about speeding up and slowing down. Let us discuss example number 16. A particle moves along a horizontal line. The particle's displacement in meters from an origin O at time t seconds is given by the formula S of t equals 4 minus 2 sine 2t. First task is to find the velocity and the acceleration. So knowing that this is our displacement, or S of t, then our velocity is equal to the first derivative of s. So the derivative of this is 0, so we get the derivative of the second term. So we have negative 2. This is in the form uh, sine u, okay, sine u. And the dy dx of sine u is cosine u. So minus 2 cosine 2t, but this is a chain rule. We get the derivative since our u here is equal to 2t. We get the derivative of u in terms of t, and that is 2 times 2. Simplifying, then our velocity is negative 4 cosine 2t. Next one, we get the acceleration. The acceleration is the first derivative of the velocity, or the second derivative of the s of t. So we have here negative 4. So the dy dx of cosine u is what? Negative sine u, where u equals 2t and our du over dt equals 2. So we have here the derivative of this is negative sine 2t times the derivative of u, which is 2. So this gives us, how much is this? 8 sine 2t. Okay, so we're done with letter A. Let's answer letter B. Find the particle's initial displacement, velocity, and acceleration. So from the previous slide, we're able to get our velocity and acceleration. Now we're going to get the initial displacement. That means our t is initially. So remember that t equals 0. So let's do s of 0. So that's 4 minus 2 sine 2 times 0, right? So that's equal to 4 minus 2 sine 0. By the way, this is non-calculator exercises, so you must know uh, the coordinates of your unit circle. So let me draw here. So this is 0 degrees. So what are our coordinates here? We have our cosine is 1 and we have our sine 0. So we can take that value, 4 minus 2, and sine 0 is here. Look, it's 0. So the answer is equal to, let me write here, it's equal to 4. 4, okay. So that's the displacement in meters. Okay, what about V of 0? So our V is negative 4 cosine 2 times 0. So we're looking for negative 4. We're doing this one by one because this is an calculator activity. And we get the cosine 0. What's cosine 0? Cosine 0 degree, our sine is 1. So negative 4 times 1 is equal to negative 4 what? Meter per second, because this is velocity. Now for acceleration, a of 0, we have 8 sine 2 times 0 is 0. And then we have 8. What is sine 0? Sine 0 degree, the sine is, this is cosine, and this is your sine. So sine of 0 degree is 0. Therefore, our acceleration is 0 meter per second squared. Okay, we'll do letter C in the next slide. Okay, let's answer letter C. We are asked to find the time when the particle is at rest. We know the particle is at rest when our v of t is equal to 0 and our v of t is equal to negative 4 cosine 2t. This has been solved a while ago. Then we have to identify whether the movement from the time it's resting is going to the right or going to the left. So let's solve for v of t. Negative 4 cosine 2t is equal to 0. So our cosine 2t is equal to 0. Okay, let's consider this as just the cosine theta equals 0. So we identify what is this theta or 2t. What are these angles that has cosine, which is equivalent to 0? Okay, so remember that this is a manual kind of task. So you need to uh, have an understanding that this could be done. This could be solved using unit circle. Okay, so let me write here in the unit circle. So it doesn't show clearly. So in a unit circle, okay, let's have this. Okay, unit circle. So where is our cosine or x value equals to 0? It happens when our angle is pi over 2 because the coordinates of these are 0 and 1. And it also happens 3 pi over 2 where the coordinates are 0 and negative 1. Remember that this is your cosine and this is your sine. So the two values by which you can have cosine of 0 is when you have pi over 2 and 3 pi over 2, or 90 degrees and 270 degrees. But our t, because this is 2t, so we're looking for only t. So dividing both sides by 2, it appears when we have pi over 4 and uh, 3 pi over 4. So these answer the question when the particle is at rest. Okay, is it moving to the left or to the right? Okay, let's continue. Let's try to find whether from that point it's going to the left or to the right. So how shall we do that? Please pause this and think for the answer. Okay, what we're going to do is to use the sign diagram where this is our v of t, v of t, or the velocity or the first derivative of s. Now we know that we're looking for the time we're looking for the displacement from 0 to 4. So 0 to pi, sorry. And then we have here, it stops at this point. These are our critical values, 3 pi over 4. Now what we can do is to find the test point. Okay, so pi over 4 is here. Okay, so between 0 and pi over 4, what's an angle less than that? Pi over, we can use pi over 6, right? Pi over 4 is 45 degrees and pi over 6 is 30 degrees, so it's less. So we can use the test point here, pi over 6. So v of pi over 6 equals negative 4 cosine 2 times pi over 6 is 2/6 or 1/3 of pi over 3. Now we have negative 4 and look for the value of our cosine over 3. Where is this? Cosine pi over 3 is in the first quadrant. The cosine here, or the x value, is positive. So 4 times positive number is negative. 4 times positive is negative. So negative there. Okay. Now we choose a test point from pi over 4 to 3 pi over 4. 1 pi, 2 pi, 1/4, 2/4, 3/4. So we must find something which is somewhere here. Okay, so we can use as test point 2 pi over 3. Why are we using these angles? Remember that you have better use special angles like 60 degrees, 30 degrees, 45 degrees, and 90 degrees. Okay, now this is in radian, so we're using radian. Is it really, it must be less than, between pi over 4 and 3 pi over 4, the test value must be less than the 3 pi over 4. So how do we check that? So we go to our elementary algebra. We're comparing 2/3 and 3/4, right? So this is 9 and this is 8. So 2/3 is less. So it's here. It's less than 3/4. So we can use that as our test point. Now let's continue. Where are we? The velocity or time is 2 pi over 3. So negative 4 cosine uh, cosine 2t. So 2 times 2 is 4/3 pi. So negative 4, and you look for the value of 4/3 pi. Where is 4/3 pi? So we have here 1/3, 2/3, 3/3. So 4/3 is somewhere here, no? So in the third quadrant, what is our cosine in the third quadrant? It's negative. So negative times negative is positive. Okay, so we look for a test point between 3/4. This is 3/4. 1/4, 2/4, 3/4, and pi. So it must be somewhere here. Okay, so I think we can use 5 pi over 6. So let's check. So it must be greater than 3/4, but less than pi. So 3/4, and let's say use 5/6 pi. This is 18, this is 20, so it's greater. 5/6 is greater, so it's here. Oh, uh, we can use 5/6 pi. So it's negative 4 cosine 2 times 5 is 10 over 6 pi, which is the same as negative 4 cosine 5 pi over 3. Okay, it's negative 4, and we look for the value of 5 pi over 3. Where is 5 pi over 3? Let me erase some things here. Okay, so let me do that again. 5 pi over 3. 1/3, 2/3, 3/3, 4/3, 5/3. So it's in the fourth quadrant. Fourth quadrant. In the fourth quadrant, what is the value of our cosine or x? Is it positive or negative? Positive. So the answer here is, wait, negative. Sorry for my. Let me continue here. Answer in letter C because I don't know what happened. Anyway, we have this P of t 0 pi over 4. These are our critical points. 3 pi over 4 and then pi here. So we already know this to be the time when it's the velocity is at rest. So when is it moving left and right? By the way, we have here negative, positive, and negative from the previous slide. So it's moving to the left when your t is greater than 0 and less than pi over 4. And also when we have, where else? From 3 pi over 4 up to pi, it's moving to the left. And it's moving to the right from that point where t is greater than pi over 4 but less than 3 pi over 4. Okay, so we use this sign diagram to tell whether it's moving to the left or to the right. Although it's not in the instruction, let us try to find or to draw the sign diagram for letter C. So what we're going to have is S of 0, and our S is 4 minus 2 sine 0 degree. So remember, we have sine 0 degree here. We have the coordinates 1 and 0. So we have uh, 4 minus 2 times 0. So it's simply 4, right? Okay, so 4. And then S of pi over 4. So 4 minus 2 sine 2t. So 2 times pi over 4 is pi over 2. So we have 4 minus 2. The sign here, our coordinates are, coordinates in here is 0 and 1. So we have 4 minus 2 times 1 is equal to 2. And then we go to S 3 pi over 4. These are our time range address. So 4 minus 2 sine 2t. So 2 times 3 is 6 fourths. And 6 fourths is 3 pi over 2. So 4 minus 2. In 3 pi over 2, our sign here is negative 1. So times negative 1. So 4 plus 2 equals 6. And then finally, we get our pi. So that's 4 minus 2 sine 2t is 2 pi. So 2 pi is at 0. So we have 4 minus 0 equals 4. And then we do our sign diagram here. This is our S of t. We're just trying to check on the, and then later on we do the displacement if it's correct. But this is not part of the instruction. So at S of 0, we are at 4. Let's say we have here 4. This is at at t equals 0. And then at t pi over 4, we are at 2. So we move to the left. So that is right. We're right after all that we move to the left. So from here, it goes here, and this is a time equals pi over 4. And then from here, we move to 6. So from here, this is a t equals 3 pi over 4. And then we move back to, from here, we move back to where it is 4. Time equals pi. So what's the displacement? It goes to, look at this, it's from 4 and then here and then go back here and then there. So we end up at the same point. So there is no displacement at all. So our displacement is equal to 0. Now let's verify this by solving letter D. Let's solve letter D, the final answer. Uh, we will be using calculus, but let us try to compare this with our answer in displacement using motion diagram. We got 0. Okay, so the displacement is of t equals the integral of bt dt from a to b. So we have here from 0 to pi, shown here. That's our boundaries. And then our v t is negative 4 cosine 2t and dt. Okay, integrating this is actually the same as taking out constant. So cosine 2t dt. Okay, notice that this is in the form of integral of cosine linear function with linear function dx, which is equal to 1 over a, and then the integral of this is sine of cosine is sine, and then just copy the angle. Okay, now we don't write plusing anymore because we have boundaries. So this is the same as negative 4 uh, sine 2t times 1 over a, which is 1 half. And then we evaluate this from 0 to pi. Let's simplify. We have negative 2 sine 2t. Then we evaluate this from 0 to pi. So let's try to find f of pi. So negative 2 sine 2 times pi, and negative 2 sine 2 pi is, okay, if we're going to draw the figure again, 2 pi here, 2 pi is here, and the coordinates are cosine is 0 and sine, no, sorry, my mistake. Our cosine here is 1, okay, 1, and 0y, okay, this is 1. Okay, so let's go back here. So negative 2 and sine 2 pi is 0, so that's equal to 0. And then we get f of 0 degrees. So negative 2. So sine 0 degrees also here. So it's the same as 0 equals 0. And then subtracting the 2, we have the displacement equals 0. We have already proven this using motion diagram, the one we solved in letter C. Let's explain example 17. A particle moves along a straight path or straight line, so that its velocity v meter per second is at time t seconds is given by this formula. And then when t equals 0, the displacement at from a fixed origin is 5. And then the task is to find an expression or an equation for s of t. Okay, quite simple, right? So what we're going to do to find s of t is to integrate the velocity dt. So we have here, we integrate 4 sine t cosine squared t. This could also be written as 4 times the integral of sine t cosine squared t dt. Okay, pause for a while and try to recall the best rule to follow in integrating this function. Remember, even if you are using calculator, your calculator will not give you the integral of this number, so you have to do it manually. Okay, ready? So what we're going to use is the recently discussed rule, use substitution. This is like a product of two numbers. So when we're dealing with products and we can see that one is derivative of the other, then we can use substitution. So let's make our u equal to cosine t. So if we're going to rewrite this, it's going to be 4 sine t u squared dt. So what is dt? Again, the derivative of u in terms of t is negative sine t. So our dt equals du over negative sine t. So we can write here du over negative sine t. So this cancels out. So we have a negative sign which we can move uh, or we can factor out. So we are integrating u to du, which is quite simple. It's just a power rule. So the answer is negative. Let me choose this one. We have, it doesn't show. Okay, negative 4 integral of u to du is u raised to 3 over 3 plus c. So s of t is negative 4. Let's return u. U is, what is u? Cosine t. So cosine t cube or cosine cube t plus c over uh, over 3. This is our s of t. And it's not complete because we have c here. Remember, uh, to write the whole equation, it must be complete. We have to find the value of c. And remember also that we have this. So it is 5. S of t is 5 when our t is 0. Negative 4 cosine cube of 0 degree plus c over 3. So we have 5 equals, what is cosine 0 degree? It is in the first quadrant. Okay, this is your 0 degree and the coordinates are 1 and 0. So it's not in the first quadrant, it's quadrantal. Okay, so negative 4 over 3 times the cosine 0 is 1 plus c. Okay, we have some space here. So performing the algebra, I'll just make this shortcut because we don't have enough space. So this is just simple algebra. This will give you a value of c which is equal to 19 over 3. That is c. But that is not what we're looking for. We're looking for the expression for s of t. So s of t equals, let's go back to this one, negative 4 over 3 cosine cube t, and then we just replace this one by 19 over 3. So this is the expression for s of t. Letter B, find an expression for the acceleration. So letter B, how do we find the acceleration? A of t is the first derivative of your t. But our v of t, we have here. Okay, so derivative, let us write it here. Your v of t is equal to 4 sine t cosine squared t. What rule shall we apply? We use product rule. So we have here product of this and this one. So let's say this is your f and this one is your g. Now we get the first derivative of f. It's equal to, what's the derivative of 4 sine t? It's 4 times the derivative of sine t, which is cosine t. And then let's find the derivative of g. Cosine 2 squared. So what rule is this? Chain rule. for this part. So we have derivative of the function. What number am I using? So we have 2 cosine t is just like class u squared t, right? So 2 cosine t or 2u times the derivative of u, where u is equal to cosine t. So here the derivative of this is 2u and u is cosine t times the derivative of u, which is negative sine t. Okay, as I said, this follows product rule. Okay, what's that for product rule? So we will use f g prime plus g f prime. So copying it, we have 4 sine t, 2 cosine t minus sine t plus g is cosine squared t and f prime is 4 cosine t. Okay, this part. Okay, we can simplify this. So 4 times 2, we can write that as 8, but this is negative here. So that gives you negative 8 sine t times sine t is sine squared t. And what else is left? Cosine t. Okay, we are just doing this class. Yeah, distributing. And then the other side, this is equal to cosine squared plus cosine is cosine cube t, and we can put 4 here. Okay, so this is the expression for a of t. Although you have calculator, this could not be done in the calculator. You have to do this manually. We find the acceleration, velocity, and speed of the particle when v equals 6. Here you can use the calculator. What is that function? The derivative, you can use this function derivative at a point. So for letter C, part 1, we find the acceleration of the C. Please go back to previous slide and find out what our uh, model equation for a of t. So we just have to make this a of 6 derivative at a point. Okay, so that's equal to 2.94 meter per second squared. Again, you go to dy dx, and our a, what was our a? So uh, it's a long equation. So go back to previous slide. You just copy this a of t. Okay, this is the function. Copy, and then x equals 6, and it will give you this value. Okay, for b, you have v of 6. The velocity, this is the velocity, so you encode this in your calculator, derivative at a point, or point is 6. It will give you a value which is negative 1.03 meter per second. Now for the speed, speed is just like displacement and distance. So speed related to distance is the absolute value. Let it be of 610, which is speed is the absolute value. So let's give you 1.03 meter per second. Okay. Now we can answer here letter D. Let
erase this. So for letter D, determine whether the particle is speeding up or slowing down. How do we know if it's speeding up or slowing down? Again, remember our rule. We just need to compare the acceleration at that point with velocity at that point. And you look at their signs. Acceleration is positive, velocity is negative, so they are of different sign. And if different sign, you can say that the particle is slowing down at time t equals 6. To answer the last question, we're looking for the displacement and the distance. So this is absolute value. Remember that. So S of t equals the integral of the velocity. Remember, this is the formula from A to B. So we're looking for from 0 to 6 of 4 sine t cosine squared t dt. Okay, you just get your calculator and find that the answer is 0.153 meters because we're talking about displacement. Now for the distance, so this is the displacement. It's actually the net length. And S of t here is equal to from A to B of Vt, absolute value dt. In this case, we have from 0 to 6 of 4 sine t cosine squared t dt. Okay, this will give you 5.18 meters. Okay, so if you don't know where to find the absolute value, it's in the catalog. I think that's after number 9 and next to number 9, the catalog is there. Practice working on these exercises. Accumulating rates of change. Let me read this. The velocity function is the rate of change of the displacement function. So we already know that the integral of Vt dt is the same as the displacement from of time 2 minus time 1 for the origin, and that the integral of Vt represents the net change in displacement over the interval time 1 to time 2. And this concept can be extended to other functions that represent the rate of change of a quantity. So you look at this formula, the rate of change dt is the rate for time 1 minus rate in time 1, where the time is, where r of t is the uh, derivative of r of t. Okay, example 18. A culture of bacteria is started with an initial population of 150. The rate at which the number of bacteria changes over a 1-month period can be modeled by this function, that's the rate of change, where r is the rate of change in the number of bacteria on day t. Find the population of bacteria 15 days after the culture was started. So we find the net change in the growth of bacteria. So we can find that by finding the derivative of e raised to 0.256 t from day 0 to, or from the initial day to 15. And you can use your GDC under integration, evaluation of evaluating integral. it will give you 178. This is actually the change over the period of 0 to 15 days. There is a growth of 178. And so on the 15th day, how many bacteria are there? Are there only 178? Yes or no? On the 15th day? No, 178 is the growth or the rate of change. We started with, the initial is 150. So we go to the initial 150 plus the change or the accumulated uh, growth 178. So that means at the end there are how many? How much is this? Uh, 328 bacteria. Try solving these exercises.